Alright, hello. So I haven't streamed in a while. This is because of reasons. I was just too lazy to do that. But today this is a very spontaneous, totally unplanned stream. And today I will be coding an app to teach me how to play music. And the inspiration for the app is caetera, which basically is your typical learning app, which allows you to type stuff. I mean, you have to retype stuff and then you learn along the way, you get some stats. And I want to do the same thing, but for music. So I have prepared a prototype to check if that's feasible. So we have a basic React app which uses the WebMIDI API to use the actual keyboard controllers. I have a Alesis V61 hooked up to my computer here. So that's a nice 61 keyboard, not that one, yeah, this one. And yeah, I want it to be able to show me random notes and ask me to play it. So as you can see, here is the state of this application shown in real time. So when I press keys on the keyboard, you have to believe me that I'm pressing them right now. It displays which are being pressed in real time. Here are the keys that I'm supposed to play. As you can see, they match what's displayed on the score, on the staff. And if I play C, D, E, F, it highlights the notes. And as you can see, that's displayed. So the notes are displayed using the Vex flow. By the way, I'm using Chrome instead of Firefox because Firefox did not implement the WebMIDI API yet. Chrome did, so I'm using that unfortunately. I prefer Firefox because freedom and Google monopoly is bad. But we'll have to do with Chrome for now. Actually, this is Chromium, but that's fine. Yeah, and basically this is a nice JavaScript library to allow for easy rendering of music notation. This is all SVG, so I can zoom in, zoom out. It works great. And I wrote a component called music, which basically uses the use effect hook to redraw using Vex flow. It's just the target is the div, basic div, and it just renders the music that's passed to it via the notes prop. Via the notes prop, and it just every time it changes, it renders it to the div. And you can also highlight notes. So this array contains the indices of the notes that should be highlighted with red for now. There's the width and height in pixels. I will have to do it in a smarter way, but for now it's just hard-coded. And yeah, so we use the reference. We get a reference to the element. So that Vex can render to it. We create the renderer, create the score, and then we have the notes. We render the notes, and actually yeah, so that's what we do. And actually, because we have the notes as an array, as we can see here, and Vex flow needs to have notes in this format. So like we have a quarter note before, then comma separated notes there. It is assumed that they are also quarter notes because the first note is a quarter note. If I wanted to change it, I would just do this for half note, etc. and a full note with one, but for now it's this. So this is the key and the octave. Yeah, so we have a little helper function here that just converts the first note to the quarter note, and the rest are just added after commas. And yeah, for now we have to have 4 notes because they're quarter notes, and VexFlow does check whether the stuff is full, and it defaults to 4x4, so we need 4 notes, 4 quarter notes to fill it. And yeah, so that's what I have for now. And yeah, so for MIDI, we're using WebMIDI. I played around with it. So I have this hook, which is basically a wrapper over use effect, but what it does when the component first appears on the screen, it asks the browser for the MIDI access, and then it just hooks the callback that's passed as the parameter to the onMIDI message event. And of course it handles unsubscribing from the event when the component is unmounted. Yes, so basically we can use it like this. This is actually quite nice. I use it in here. So basically what I do, I just use MIDI event. Oh wait, hang on, there's another one. I also have a helper function that basically this MIDI to event converts the event, the raw MIDI message, which is just an array of bytes, and it just parses the message data, and yeah, so this is the type. So for now I only support key up and key down, which is all we need for this app. So it just gives you the type, whether it's up or down, and the key, it converts it into regular letter and octave number instead of the MIDI number. We have a function to convert both ways. And the strength, but that's not necessary now. I may use it later to play the notes, but not now. So basically what we have here is I'll actually remove all this for now because this is overcomplicated and I want to rewrite it. So I'll show you how it works for now. So we can just ignore this and I will show you the events. So yeah, now if we restart, of course it doesn't do anything because I removed most of the code. But if we open the console, and I'll zoom in so that you can see better. First it subscribes to all the MIDI devices in the system, and then if I press a key, we can see the messages logged, and 144 is key down. And we see that I press C4 with this strength, and now I press C lightly. You can see it's 60, 59, 57, and if I slam it, you can see it's going to 127, which is the max for MIDI, because I think it goes from minus 127 or something to plus. It's basically a signed byte. Yes, so this is the messages we get, and now what we want to do is we're gonna describe the state. Yeah, hang on just a second. Alright, I'm back. So let me just open up a notepad. I'm using the fact that nobody watches me, because you could just copy the link and write here, but yeah. Alright, so what we're gonna do here is first we need to figure out what state do we need. So for sure, can I actually, I'll use, why cannot this be fully white? I don't know. And let's do monospace. Yeah, great. So we have the, so we want to, first we want to describe so of course we're gonna have to have a list of notes to be played, so like C4, E4, D4. This will be, and this will be shown to the user on the stuff, and then the user will have to play the notes. So as the user plays notes, we're gonna have to have like position of the user. So if the user is at position 0 and presses the C key, the C key, correct, then the position will advance. So yes, so we can advance the position, and then when the position reaches 4, so actually when the user reaches the 4th position, so which means it after the he played all the notes, or they played all the notes, that means we have to advance, so we're gonna have to replace the position. So because we want to, I mean, I want to do this app using like a Redux way of managing the states, so we're gonna have state and events that the state changes in reaction to events. So we're gonna specify what events are possible later, but for now we have those states, which this in the states, which should be enough for now, because honestly that's all we need to display this. So we're gonna have the nodes so that we know what to display here in this stuff, and then we're gonna have the positions so we know which nodes to highlight. So for example, now we have position 0. After I play C, oh, I removed this. Okay, so after I play C, the position will be 1 and this will be highlighted, and then I'll play the D and the D will be highlighted, and so on. And then after we play all the notes, we want to generate some more random notes. So first, events. We want to have the events. So the possible events, actually this is monospace, maybe it should be, actually it's more, if I choose normal it looks better. Yes, so what events are we gonna have? So of course you wanna have a key down event with the argument of the key that was played, and that's honestly all we need here. So yeah, later we'll extend this to count errors and stuff and show some statistics, but this is the basics. So now I'm gonna start Googling. I know there's something like use reducer. Yes, so this is perfect. Why it doesn't work? Okay, so the link does not work, but that won't stop us. Here we have the description of how to use reducer. So let's get rid of this for now. Let's get rid of all the state. Yeah, so we have a we are back to a Hello World app, and now we can start writing. So we can see that first, of course, to remove this. This was an ugly hack that we don't need anymore. Yeah, and here's a typo. Yep. Okay, so we have a Hello World app here, and we need to import the use reducer, and then let's see. First, okay, so this is gonna be state and dispatch. So the state will be the object we described here, and dispatch will be the function that we call to pass events to modify the state. So so this is it. So let's do use reducer. Okay, and what do we have here? First we have the actual implementation of the reducer. So for now let's get one that does nothing, and I'll actually do this so that it's easier to read. What's next? Initial arg. So initial arg is probably the initial argument that is passed to the... Okay, so we have alright, so we have an example, and we can see that this initial arg is actually we can use it with just 2 arguments, and we have the initial state here. So let's go with toPlay, and let's start with C4, D4, E4, F4, and we don't need those quotes here. Yeah, so this will be the initial state, and yeah, let's see. Let's try to render that state so that we can see it in real time. Okay, yeah, we see the state is looks the way it should. And what else do we have? Position. Okay, so now that we have the state, we can work on actually rendering the user interface based on the state. So first I'm gonna show you how the nodes to easy score function works. So I'm gonna pass the nodes that we have here to the nodes to easy score function, and as you can see, it just converts it to the format that easy score can use to render the nodes. And now let's replace this with actual call to the music component, which uses easy score to render the nodes. So nodes to easy score, because we have to convert it, and then we pass the state here, and there we go. And if I change the initial state, as you can see, it updates wonderfully. So this is great. And now the position is 1. So let's pretend the position is 2. So we have played the first note and we have played the second note. So those two should be shown in red. So what we want to achieve is we want the highlighted notes here to be 0, contain 0 and 1. So we want to highlight the 0 note, so the first one, because array start at 0, and the second one, which has the index 1. If we save it, we see that works, but we want to turn this into the array we need. So for now I'm gonna just play in the console to see. If we want to create, basically we have a number, but we want to turn it into an array containing the numbers from 1 up to that number. So if we have 1, we want to turn it into this. Wait, no. If we have 2, we want to turn it into 1, 2. If we have 3, we want to do 1, 2, 3. So if we create an array, I've seen this hack somewhere on the internet. We can create an array with a certain number of arguments. So let's say we want a 3-element array. And actually, because everything in JavaScript is actually an object, so you can do keys, which will return the keys. But this is an iterator, and we want to convert it into a list. And as we can see, this is a great way to generate numbers from 0 to a number, excluding the number, which is perfect, because this is what we want. So if we change this into, and here we do state position, as we can see, it does not work correctly. The position is 2, so this should be another 0 and 1. And if we have 0 and 1, this should highlight both the nodes. So why does it not work? Let's try again with 0 and 1. It works. It doesn't here. So let's try showing this. See what it generates. Oh, and now I see. I notice right now I have a typo. So if we replace this with position, we replace it with position, and yeah, turn it into an array. We have 0, 1. Great, so I'm gonna fix it here. And there we go. Now if we change the position, it works correctly. Great. So now we have a way to choose which nodes are displayed, and we have a way to highlight some of them. So now we have to react to the changes. So first let's have a way to receive the keyboard clicks from the keyboard, from the MIDI keyboard. So for that we're gonna use the use MIDI event hook, which is which I have here, which basically uses the use MIDI hook I wrote earlier. I'll show this. I'll put this project up on GitHub, and you will be able to see the code, which subscribes to the events basically and unsubscribes when the component is unmounted, so that we don't leave any event handlers lying around. Yeah, so if we go back to app.js, sorry for my chair, I'm getting a new one in like after the weekend, so there will be no more creaking sounds, hopefully. Okay, so we have the use MIDI event, and let's do a console log for now to show you again what type of data we are working with. So I'll switch the console. So as we can see, we are subscribed to the MIDI controllers, and if we press a key, we receive events on key up and key down. So what we're interested in is the key down event. So if we have, so we can do the following. We can compare the event type to the MIDI key down constant from the MIDI.js module. So if we see that this event type is key down, we can say key pressed down, and we can have the event key shown here. So now if I click, we see in the log which key is clicked, which key is pressed, so this is all we need. So yes, now that we have this, we want to modify the state based on that. So how do we do that? We go back to the reference and see how to actually write a reducer. So what is a reducer, you may ask? A reducer is a function that takes the current state, so before any changes, and an action, an event that happens, so for example a key press, and returns the new state. So it modifies, it kind of shows us if we have a certain state and an action happened, what should the state be after that action. So in our case, we can switch on the action type, or actually, yeah, okay. So let's define some action types. It's good to have some constants so that the autocomplete and all the other type checking stuff, not even type checking, but undefined variables and stuff, so all that works. And the events we will have in the following forward. So we want to encode the events as the following. So we will have type, so for example action key down. I'll actually use key down because for consistency with this. And then we're gonna have key, which is the node. So this is all we need to know to update the state. So let's switch on the action type. And in case we don't know the type, so we're gonna do something similar to this. So we're gonna throw a new error, but we're gonna add a message, not like them. So the message will say unknown, actually unknown action, and the action will be unknown action type. Now, if we have a action key down action type, then we can do something with the knowledge that the user has pressed the key. So for now, let's return the state without any changes, and let's just see if it works, if it actually receives the state, this event. So action dispatch, and let's log the action. Of course, now if we press anything, we won't see this action dispatched message, because we first of all we have to tell React to use this reducer, and then what we have to do is actually dispatch this action. So this is where the dispatch function comes in. Actually we're gonna have a so now when the event is received and we log it here, let's remove that log and replace it with dispatch, and now we can create this object similar to this one, except we will actually fill in the key that we have from the MIDI event. So the type is of course action key down, and the key is the one from the event. And now this should work. If I press a key, we see that the action gets dispatched. So now we need a way to determine which key needs to be pressed, and for that we can use the position. So we go to the reducer, because here we know which key was pressed, and now we have to check whether the key is correct, and if it is, we can advance the state, so we can mark this as pressed correctly and go to the next node. So for this we're gonna so we have all the state, the current state available here. So if we actually, for now we're gonna log this. So if I want to show you the state. So the position should be 0, and the node at the position should be the first node that we need to click. And actually not nodes, it's to play. Because, and now look, if we press a key, we see that the position is 0 and the first node is A4. If the position was 1, we would get the second node, which we're gonna use, because every time we click a correct key, we're gonna increase the position, so we'll naturally know what is the next node. There will be a problem when we reach the end, but we will handle this later. So for now, we'll just add some constant for readability. So expected node is the node that this is the node that we are supposed to play. As we see here, it is shown here. So let's do expected node. Let's add some more information to the logs. Yep, you see. Yes, actually I'm gonna do this. I'm gonna move this below. Yeah, we want to have some logging, so we see that everything happens as it's supposed to. Okay. So we see that the expected node is A4, and we see that the pressed node is A3, B3, let's see. This is A, is this A? Yeah. So yeah, now we know in the situation where the expected node and the pressed one from the event is the same, we should advance the state. So let's check if the expected node does not match the key that was pressed, we just return the state as it was without any changes. So nothing happens. And let's see. Oh yeah, sorry. I actually pressed the correct node and we don't handle that yet. So, and let's actually add some more logging so that we see that it works. So yeah, if we press a key, the event gets dispatched. From here, from the dispatch function, it gets passed to the reducer, which notices this is not the correct note because it expected A4, we press D4, it tells us wrong note. Then now, if the note is correct, we should... if the note is correct, we should advance the state. So what does it mean? First of all, actually that's all we need to do for now. We need to increase the position. But we cannot do this like this. Why? Because the way reducer works, it is supposed to be a pure function which does not mutate any state. So it cannot change anything in the state. Actually it can, but this leads to bugs. Instead it should return an entire new object with the change you need. And why is that needed? This is because if we do it like that, we avoid many bugs and we have many nice possibilities. For example, because we are sure that this is a pure function which does not depend on the state except the parameter, so it doesn't change anything outside the function. We know we can just replay all the events and reach the same state. So this is great for debugging. There are, at least for Redux, there were a lot of plugins. There was a plugin for developer tools which allowed you to travel in time in your app, and this is really helpful with debugging, and this is only possible if the functions are pure and do not mutate the state directly. So instead of doing this, we can do a nice we can use a nice trick, which is if we return an object, we can do this. And what does it do? This object now contains everything that was in state, because we sort of unpacked it into this object we defined here. And now, the way JavaScript works, if we have a key like a equal to 1, if we do it twice, the second one is treated, this one is ignored, and the second one is used. So, if we have anything in this state that we have to replace, we just have to add it below. So now, remember, in the state, we have the previous value of state. So we basically want the previous value plus 1. And now if we save this, look, I'm gonna press the wrong key. It's D3, it expected A4, it does not work. C, B, A, okay, so this is C, B, A. I don't know how to play it yet, so I'm taking some time to find the notes, because this is why I'm writing this app. I'm writing it to learn. Okay, so if this is C, this is B, this is A, so I'm gonna press A4, hopefully, if I didn't mess this up. And great! The action got dispatched, the node was correct, and we increased the position. So, next we are supposed to play the D, I suppose. I don't know how to read notes yet. So this is C, D. And it works. Let's press C again to see if... Yep, as you can see, this is the wrong note. We're supposed to play an E. If we play an E, it works. If we play an F, it works. And now, as you can see, if I play another note, the expected note is undefined. Why? Because we increased the position to 5, which is beyond which is more notes. We have only 4 notes, there is no note at position 5. So what are we supposed to do in this case? Well, we want to generate some new notes. So now we want to handle the situation where we want to generate some new notes. So for now, we're gonna see, we want to replace nodes, but only if the position equals, so let's see, actually, let me do it, let's go back to showing the state. Now we see, okay, of course. I'm gonna remove this. Yes, so now, I'm gonna play A, the position is as 1. D, E, okay. And then if I play F, the position is 4, which is equal to the length of this array. So we know that this is the boundary condition. So we want to replace nodes, but only when the state position, oh, and one more thing, we want to see, because we want to see if we need to add 1 to this check, because this is the previous state. So let's see. We press the A, C, this is not C, D, okay, E, and now let's see. The position right now is 3. So now, when we press this, what is this, the F, when we press this F, this argument, this action will be, we will see that it contains, we press the key F, but this will be the previous state. So this will be the state before pressing the key. So the position will be at 3. So we need to check if the next position, so state.position plus 1, is equal to state.toPlay length. So now, if this is true, we have to replace the node. So for now, we're gonna replace it with just something hard-coded. I don't know, whatever. And what happens if we... this is a ternary operator, so this happens when this is returned. The nodes will have this value if this is true, and if it's false, we want to have the same value as it was before, so we just return this. And now let's try that again. So what we're supposed to play, so this is A, this is D, E, F, and okay, we instead of course, I used notes, and I was supposed to use toPlay. So we're gonna have to fix that. We want to replace toPlay, not nodes. So as we can see, we added a new key, which was not there before. So it's good to have this state display or use a browser plugin that displays the state for you, because it helps for developing. We could notice that bug immediately. So let's try again. This is A, this is D, E, F. And as we can see, everything got replaced. And there we have another bug. We can see that we still have it highlighted. So what we should do is do another check like this, and if we're replacing if we're replacing the, if this is the end, if we're replacing the nodes, we're gonna have to reset the position to 0. And let's see if this works. This is A, D, E, F. Great. And now let's play C, C, C. Another C, does not work. C, great. So okay, this is a little bit, this is not great code because we checked the same thing twice. So instead, we can do the following. We can here check this. So if the state position is equal to, so this was the last node. So let's see. Let's write here what this. We're gonna write in the comment what this condition actually checks, so that it's easier to understand later. So, if this was the last node, we're gonna return the state, but with new nodes. We don't have to do this ternary operator here because we already checked that we need to replace the node. Yeah, and let's write a to-do item, generate the nodes, randomly. Great. And let's set the position to 0, so this will be the new state. Otherwise, now if the if condition is true, we return, so we will not reach anything after this if. So if this is not true, this code will get executed, so we know that we do not want to replace to play, because we haven't reached the end yet. And here we know that we want to increase the position. Now this code is much easier to read. Otherwise, yeah, so let's add some comment. Actually, this one. Yeah, sure, okay, that's all we need. And let's try wrong key. Where is A? Here. A, D, E, F, C, 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 and B. There we go. It reset. Try again. C, 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 B. Splendid. It works. So I guess this will be it for now. We have a nice application. I'll upload it to my GitHub. So I'll add the link in the description to the repository. And yeah, and the next time I'm streaming, if I'm streaming writing this up, I'm gonna add a random generation of the notes, because it's not as easy as just choosing a random letter and a random number, because that is not a real-life scenario really, because you almost never jump randomly from the left side of the keyboard of the piano to the right or something like that. There are some rules which usually the music you play is governed by, so we want to have a random generator that generates something that fits those rules, and I will have to research that. So I'll do that off stream, and then I'll come back with the findings. And after doing the generation, maybe I'll add some stats. So maybe like the accuracy, how many wrong notes you played, how many good notes you played. And eventually we're gonna also implement some rhythm checking, so that, because right now you can just play it at any tempo, or actually with random intervals between notes. So let's say I'm gonna play the C, then wait some time, then press C quickly twice, then B, it just accepts it. This is fine for the beginning when I'm just learning to read notes and play them, but later I will want to increase the difficulty. And one way to do that would be to actually check whether I'm playing at correct speed. Yeah, so that's it for now, and see you later. I will try to make a schedule, but I'll need to catch up with my studies, and then I'll see what I can do with the streams. Yeah, okay, so thanks and bye.